All right, and we are back for round three, baby. My voice is feeling a little bit better, so I think we'll be good to go on this one. So I'm just going to jump right into it. Blockchain Data Index, or the graph, launches on Near blockchain. So today we're talking about the graph with the Near blockchain, the first non-EVM chain that they are indexing. So first of all, I just want to say that this is purely educational. This is not financial advice. I'm just giving you an engineer's perspective on some of the crypto infrastructure that is interesting to me, and hopefully it's interesting to you as well. Today, I really want to focus on the Near blockchain itself, and we're going to learn a little bit about that, but there's kind of a lot to go through, so I'm thinking of separating it into two different videos. So the Near, so far what I've kind of understood, Near is very similar to Ethereum in some sense, and then has some similarities with the Bitcoin blockchain as well. But they, in their documentation, they do reference those similar or some of the differences, which I really like, because they're basically saying, we know this competitor exists and we know what they do, but this is how we can do it better type thing. So one thing I haven't actually figured out yet is when Near started. That's one thing I like to know. So we might have to circle back to that. Maybe I could just do a quick Near blockchain. However, when preparing to launch, Near released the design for protocol back in 2019. Okay, so they're fairly new. It is always meant to be a sharded blockchain, so that's one of the differences. I think Ethereum is also moving in that direction. Yeah, I didn't quite understand what the paper was talking about sharded, so let's start from the beginning. So Near, what is Near? It's a collective, a foundation, a blockchain network of thousands of community members fostering development, and then it's a blockchain. They do proof of stake. It's obviously layer one, and they say it's sharded. EVM and Rainbow Bridge were developed for interoperability among chains. How do you build on Near? So it looks like they support your typical JavaScript, Rust, assembly script, JSON. So if we go into this token, the platform just brings you to this homepage. So let's go into the tokenomics a little bit. Current price, I don't think that's, let me refresh this. Current price, 728. So they say Near is a utility token that powers a Near protocol blockchain, and then they also say it's used for, well, we'll just highlight some of the points as they come up. So who uses Near? Apps and users, validators, and delegators. Similar to blockchains like Ethereum, the Near token is used to pay for transactions by users of applications. It's pretty straightforward. Validators and dictators, the nodes which run the network, are compensated by block rewards. They do a fixed block reward system as opposed to Bitcoin, which I believe does like an exponential type block reward system, and it will typically dissipate over time, and then the rewards just become purely transactional rewards. How do I get it? Earn it, buy it from a friend. If you can store it, they have their own Near wallet. You can store it on anything that supports Near. Transfer Near, a Near drop. You can send a friend a Near drop to help them get started. I thought this was interesting. It seemed like when someone sends you a Zelle request and you've never used Zelle, they just send it to your phone number. In essence, a Near drop lets you send a link to whoever you want with a certain amount of Near attached to it. This allows app developers to onboard users and pay for their Near account. Users to send Near to their friends, whether they have an account or not. So you just receive a link. How Near drops work, they go into some of the function. I think this is the function call. Okay, I'm not super interested in the Near drop. Okay, so they have these dive deeper into token economics and more. So we're going to dive into this token economics file right now. This is just one layer deeper. So we're on the top layer of information. We're going to go one layer deeper, and that's going to be this file. So I've made it to, I will admit I didn't read the very end, like close to, I probably read about 85% of this, and so I haven't made it all the way through. It's kind of a lengthy one. I just want to spend, maybe 9 minutes going through this, so I'm not sure how far we'll get. So let's just go through this. I think it'll be helpful to just point out some of the main ideas. I should have highlighted them first, actually, now that I'm recognizing, but it'll get better in the future, I think. I already am realizing I need to get a new headset or something, a new microphone, because I don't know how well this audio comes in. So the open web is a paradigm shift. Obviously, everyone's going through this paradigm shift. And they say the principles of open web are governed by community, hackable and composable, open and permissionless, just like every other distributed thing we're talking about, user first and sovereign, and open markets. To ensure these principles are followed, a combination of efforts are required. Trustless and permissionless base layer, that's obvious. Backend for high risk and low trust serverless, decentralized application. So nothing super innovative at this point. So native cryptocurrency near, they use this little circle with an N, like a Nintendo sign kinda, to represent the near token. As a native currency, it secures the network, provides a unit of account, a medium of exchange, and third-party applications. Overall, it becomes a store of value used by individuals. So they do mention that it's more than just a utility token in some sense. I have been hearing a lot of regulations coming down on strictly utility token versus something that's store of value or medium of exchange even. Who knows? Like regulations could, this one would be affected by those regulations if they were to ever come down to that. Security of the network. Near protocol is a proof of stake network, which means that civil resistance from various attacks is done by staking near. Stake near represents a medallion for service providers that supply a decentralized infrastructure of servers that are maintaining state and processing transaction to near. Okay, staking near. Network usage fees. Value of the data. Okay, they do say something interesting. I want to make sure I don't miss it. In the long term, near becomes a representation of the value of data stored on the network and their stability across application and the use function. So one of the differences they point out between this and Ethereum, and I think we haven't gotten to it yet, but storing data is the amount of data you store is taken into account with this chain. So they'll go into a table of how it breaks down, but that's more of a sustainable outlook, I think, from my point of view. And we'll dive into that in a second. The other thing, okay, so at the launch, the Near network will have 1 billion Near tokens. Each Near is divisible by 10 to the 24 Yocto Near. Yocto is just another unit like micro or nano. Yocto is just 10 to the minus 24. So they're just saying 10 to the 24 times 10 to the minus 24 is 1 Near. So they break it down into Yocto Nears, basically, is what they're saying. Near's protocol issuance of tokens is necessary to pay network operators, also called validators. There is a fixed issuance of 5% of the total supply each year, 90% of which goes to the validators in exchange for computing, storage, and securing transactions and happening on the network. As mentioned above, all transaction fees collected by the network get burned. Therefore, the issuance of Near is actually around 5% minus transaction fees. This means that the network grows in usage, issuance can become negative, introducing negative inflation in the protocol. Since the smallest unit of account for Near is Yocto Near, like what I mentioned earlier, the system can keep its exchange price resolution as small as infinitesimal fractions of a US dollar, even with a reduction in the overall supply by 2 or 3 orders of magnitude. So here they give a breakdown of when the inflation would become negative. So I don't know how hard it is to reach this number. And I think, yeah, I don't think this is actually how it's implemented. I think this is more of an example, because they say this table includes a few assumptions, but the main point, so they say the main point of this table is to show how inflation gets affected by usage. So I don't think this is like a hard follow guide of how they're going to stick with their governance. But they do say, note that even though 1 billion transactions per day is a pretty large number for existing blockchains, which is what I thought, right? Because 1.5 billion transactions per day is hard for even some of the biggest chains to handle. That's about 11,000 transactions per second of sustained load. Also, these transactions are benchmarked as payment transactions. More complex smart contract calls will require more gas and cost more. Bitcoin pioneered cryptocurrency and the idea of fixed supply. Okay, this is where things get interesting. So at the same time, constant reduction in security rewards available to miners creates interesting issues long term with the longest chain consensus. So that's how Bitcoin works. They do the longest chain consensus. And it says for more details, read this paper. So let's take a break. Ah, shoot. Okay. I want to dive into this paper, but I'm not sure. Okay, let's dive into this paper and then we'll come back and probably take a break. Um, so what they're saying in the long chain consensus is here's a research paper that's on the instability of Bitcoin without the block reward. And what they analyzed is if the current state of the chain is here, so I'm just pointing at this diagram for a quick overview. I don't want to dive into this whole paper. But if the current state of the chain is here, and the head of the longest chain contains 100 units of transaction fees, with 5 units remaining, then the miner has one of two options. So option one for the miner is to extend the longest chain, right? Longest chain consensus, and claim 5 units of transaction fees for himself, and then leave 0 units for the next miner until the next set of transactions arrive, or the next block arrives. Or if they fork the longest chain, they claim 55 units for themselves. They basically split the number of transactions, and then they claim the 5 extra units, and then 50% of it they claim, so they have 55. And they claim the 55 units for themselves, and they leave the 5 units for the next miner. So this talks about block rewards and transaction fees. The former accounts, so the block rewards account for the vast majority of miner revenues at the beginning of the system. So that's why you fork it. But it is expected that to transition to the latter, to transaction fees, as the block rewards dwindle. Dwindle is not a better word. Maybe I'll just read this whole thing. We show that this is not the case. Our key insight is that with only transaction fees, the variance of the block reward is very high due to the exponentially distributed block arrival time. And it becomes attractive to fork a wealthy block and steal the rewards therein. So that's what this was happening. They forked it, stole the rewards, and then the next miner gets even more rewards by going off of this chain versus the longest existing chain. We show the results in an equilibrium with undesirable properties for Bitcoin security and performance, and even non-equilibrium in some circumstances. We also revisit selfish mining and show that it can be made profitable for a miner with an arbitrarily low hash power share and who is arbitrarily poorly connected within the network. Our results are derived from theoretical analysis and confirmed by a new Bitcoin mining simulator that can be of independent interest. Okay, so that's all I wanted to dive into for this paper. If you have more interest, you can follow these links and read it as well. All right, so let's back out. So that was the paper that they reference, and those were the issues that they try to address. So they say in NEAR, we address these issues by guaranteeing a constant security reward rate. This is what I was referring to validators. Instead of issuance declining independent of usage, NEAR's issuance declines with more usage of the network. Also note that in comparison with Bitcoin and Ethereum, token holders can avoid inflation by delegating validating with their stake, preserving their percentage or even increasing it. Okay, I'm going to cut this video here. We're going to stop at network usage. There's still a lot of information to go through. Network usage, storage, and the other thing I want to point out at the end of this, I was going through the community talk, the last community talk they posted, and everything I said in the last video, I don't know if you could hear it clearly because, I don't know, I had audio problems and I have throat problems, but they did say that they were making all their code more chain agnostic, which is what I said at the beginning. I said they have to remove all the code that is dependent on Ethereum specific chain, and that's what they're doing. So I think in the future it will be easier to onboard different types of chains, and I think they're planning that as well. Okay, yeah, I'm gonna split this into part 2